All right, this is video 2 of the exponential logarithmic function unit. And this is going to be a fun one. I'm so excited about this. Okay, so we're going to start off with, I just want to ask you, if you had to solve 2x equals 18, what would you do? Divide by 2, right? Because to undo 2 times x, you divide by 2. How do I undo x plus 2? Subtract, you're right. How do I undo x squared? I would take the square root, right? How do I undo 2 raised to the x? So if I undo x squared with a radical, how do I undo a x power? You'd think that you would use an x root, but there is no such thing as an x root. But there is an inverse operation, and the inverse operation of an exponential function is a logarithm. All right, so if the exponential equation were harder to solve, how would we do that? Because we can do this first one with mental math. You know that that's third power. But what if it were harder? Let's go back and talk about Clara from video 1. If Clara invests $5,000 at 6.25% interest and needs $9,700 at the end of the investment, how long will she have to wait? Like, how many years will it take for that investment to grow? Well, that's what your function looks like. You guys know how to plug that in by now. And I need to solve for time. In order to do that, I need logarithms. So today we're going to learn how to write equivalent forms of exponential and logarithmic functions. It's so easy, kids. It's so easy. We're going to use logarithms to solve some real-world problems. So a logarithm, let me move my face. A logarithm is an operation that undoes raising a base to a variable exponent. That's the plainest way I know how to explain it. And I like to describe it as another way to write a power. You can rewrite that power. So you can write an exponential equation as a logarithmic equation and vice versa. How do I do that, Ms. Darden? Well, an exponential function looks like this. Base raised to a power equals a number. If I want to undo that, then I'm going to take that power and write it down. So literally take your power, write it down, and rename it. So that's your equal sign, is that you're saying I'm going to rename it as a logarithm. So power equals a logarithm. Then you've got a base for your log. Well, whatever the base is for your exponential is the base of the log. The only thing left in that equation is the number. That's red. So if you're given log base b, so log b a equals x. How do I say that? Log base b of a equals x. Log base b of a. Log base of number. Let's try some. If I want to take 3 to the 5th equals 243 and rewrite that in log form, I would take 5 and set it equal to a log. I'm going to take the power 5 and rename it as a logarithm. The base of the exponential is 3, so the base of the log is 3. So 5 equals log base 3 of 243. All right, let's try the next one. 25 to the 1/2 power equals 5. Take 1/2, that's your power, rename it as a logarithm. So 1/2 equals log. What's the base of your exponential? 25. There you go. It's just that easy. The next one, 4 equals log base 10 of 10,000. Next, -1 equals log base 6. And let's try a raised to the b equals c. B equals a logarithm. What's the base of the exponential? It's a. So b equals log base a of c. Let's go in the other direction. So now we're going to take a logarithm and rewrite it as an exponential. I like to look for my base first. What's your base of this first logarithm? It's a 9. Well, which one is the power? Is 9 the power or is 1 the power? A logarithm equals a power. So 1 is the power. So 9 to the first equals 9. How about this next one? The base is 2, the power is 9. Next, the base is 8, the power is 1/3. See how easy this gets? If you guys want to go through this slower or again, I'm also attaching the PowerPoint to your Teams assignment so you guys can print these out and go back and or you can pull them up and quiz yourself on them. I want you to notice on this last one, log of 1. I don't care what the base is. Any logarithm of 1 is equal to 0 because in order to get from the base of the log and raised to a power, in order for that to equal out a 1, the power has to be 0. So the logarithm of 1 is always 0. All right, there's different forms of logs. A log with a base 10 is called a common logarithm. How do I know if it's a base 10? Well, if no base is written for a logarithm, then it's assumed a base 10. So for example, log of 5. If it just says log of 5, you're like, where's the base? There ain't no base written there. That means base 10. How about a logarithm with a base e? Euler's number, e. Awesome number. It's called a natural logarithm, and it's written as ln, not in. It's ln with a lowercase l. There's a button on your calculator for that. We don't get to use that kind of calculator, but that's what that means. So if you see natural log of 5 or ln 5, don't pronounce it ln 5, and please don't say n 5. It means natural logarithm of 5, and it means log base e of 5. So rewrite this in exponential form. Natural log of x equals y. What's the base? E. What's the power? Y. So e to the y equals x. How about this? Can you evaluate this? This means a base of 5 raised to what power equals 125? There you go. Log base 5 of 125 is 3. Super easy. Log of 1,000. What's the base of that? There's nothing written there, so it's an understood 10. So 10 raised to the what power is 1,000? 3. Can you do this one? There's some properties here at the end I'd like for you to look over, but if you understand how to rewrite log into exponential and exponential into log, then I don't want you to memorize these properties right here. That's it for this lesson. Nice and short.